What is Docker and why is it used?
Docker is a containerization platform that packages applications and all their dependencies into lightweight, portable units called containers. Why use Docker? Environment consistency. Works on my machine is eliminated. Containers behave identically in dev, staging, and production. Lightweight containers share the host OS kernel, so they start in milliseconds and use far less RAM/disk than vmtks. Microservices friendly. Each service runs in its own container with isolated dependencies. CI/CD integration. Images are immutable artifacts that flow through build, test, deploy pipelines. Ecosystem. Docker Hub provides thousands of ready-to-use images, databases, web servers, language runtimes.
What is the difference between Docker and a virtual machine, VM?
Docker containers and vmtks both provide isolation, but they work at different levels. Architecture. Docker runs on the host OS kernel. The Docker engine manages containers. No guest OS needed. VM runs a full guest OS on top of a hypervisor, for example, VMware, KVM, Hyper-V. Each VM includes its own kernel. Performance. Docker near-native speed starts in milliseconds, uses mbtks of disk/RIM. VM, slower due to full OS overhead, starts in minutes, uses gbtks of disk/RIM. Isolation. Docker, process-level isolation via Linux namespaces and cgroups. Lighter but shares the kernel. VM, hardware-level isolation via hypervisor. Stronger isolation, suitable for running untrusted workloads or different OSes. Use cases. Docker, microservices, CI/CD, rapid scaling, dev environments, VM running different OS types, legacy apps, strong security boundaries.
What is a Docker image?
A Docker image is a read-only layered template that contains everything needed to run an application. Application source code, runtime, for example, Node.js, Python, JVM. System libraries and dependencies, environment variables and configuration files, key concepts. Images are built from a Docker file using
Docker build.
Each Dockerfile instruction creates a layer. Layers are cached for fast rebuilds. Images are stored in registries, Docker Hub, ECR, GCR, etc. A container is a running instance of an image, created with
Docker run. Code Docker build tmyep 1.0 Docker run myep 1.0.
What is a Docker container?
A Docker container is a running instance of a Docker image. It is an isolated process or group of processes that has its own file system, provided by the image layers plus a writable top layer, its own network stack, gets a private IP on a Docker network, its own process space. PID1 inside the container is the main application process. Resource limits, CPU memory, and I/O can be constrained via cgroups. Containers are ephemeral by default. When a container is removed, its writable layer is lost. Use volumes to persist data beyond the container lifecycle.
How do you create and run a Docker container?
Use the
Docker run.
command.
Code Docker run dname myep p8080 80 engine x.
Flag breakdown.
W.
Detached mode runs in the background.
Name myep.
Assigns a human-readable name.
P8080 80s.
Maps host port 8080 to container port 80.
Engine x.
The image to use, other useful flags.
EKEY equals VILUE.
Set environment variables.
v/host/container.
Amount of volume.
rrem.
Automatically remove the container when it exits.
Restart unless stopped.
Auto restart policy.
What is the purpose of the Docker file?
A Docker file is a text file with instructions that Docker uses to build an image layer by layer. Example.
Code from node 20 alpine workdir/app copy package asterisk JSON/run npm sci production copy expose 3000 cmd node app.js.
Common instructions.
FROMs.
Base image always first.
WORKDIR.
Set working directory inside the container.
COPY.
Slash.
IDD.
Copy files from build context into the image.
RUNs.
Execute commands during build, install deps, compile, etc.
ENV.
Set environment variables.
EXPOSE.
Document which port the app listens on.
CMD.
Default command when the container starts.
ENTRYPOINT.
Fixed executable for the container. Best practice. Order instructions from least changing to most changing so Docker can cache layers effectively.
What are Docker volumes?
Docker volumes provide persistent storage that lives outside the container's writable layer, so data survives container restarts and removal. 3 storage options. 1. Named volumes, recommended for production.
Code Docker volume create mydata, Docker run vmydata, /app/data engine x.
Managed by Docker, stored under.
/var/lib/docker/volume/.
2. Bind mounts useful for development.
Code Docker run v/host/src, /app/src engine x.
Maps a specific host directory directly into the container. Changes are reflected in real time. 3. Anonymous volumes.
Code Docker run v/data engine x.
Docker creates a volume with a random name. Harder to manage, avoid in production, useful commands.
Docker volume ls.
List volumes.
Docker volume inspect mydata.
Show volume details.
Docker volume prune.
Remove unused volumes.
How do you list running Docker containers?
List running containers.
Code Docker ps.
List all containers including stopped.
Code Docker psa.
Useful formatting options.
Docker ps format, ID names status.
Custom output columns.
Docker psq.
Show only container ID tickets, useful for scripting, for example.
Docker stop $Docker psq.
Bleh.
Docker ps filter status equals exited.
Filter by status.
What is Docker Compose?
Docker Compose is a tool for defining and running multi-container applications using a single YAML file. Example.
Compose YAML.
Eh.
Code services web image engine x ports 8080 depends on DB image MySQL 8 environment. MySQL rootpissword root volumes DB data /var/lib/MySQL volumes DB data.
Key commands.
Docker compose up D.
Start all services in the background.
Docker compose down.
Stop and remove containers/networks.
Docker compose logs F.
Stream logs from all services.
Docker compose PS.
Show running services.
Docker compose build.
Rebuild images note, the standalone.
Docker compose.
Binary is deprecated, use the.
Docker compose.
Plugin, built into Docker Desktop and modern Docker Engine.
What is the difference between CMD and ENTRYPOINT in Docker?
Both define what runs when a container starts, but they behave differently. CMD provides default arguments that can be fully overridden from the command line.
Code CMD Python, AppPy.
Running.
Docker run mimage bash.
Replaces the entire CMD with
Bash.
entrypoint, sets a fixed executable that always runs. Command line arguments are appended to it.
Code entrypoint Python appy.
Running.
Docker run mimage verbose.
Executes.
Python appy verbose.
Combine pattern best practice.
Code entrypoint nginx cmdg daemon off.
entrypoint is the fixed command. CMD provides default flags that the user can override. To override entrypoint at runtime.
Docker run entrypoint /bin/sh mimage.
What is Kubernetes?
Kubernetes is an open-source container orchestration platform originally developed by Google, now maintained by the CNCF. Core capabilities. Automated scheduling places containers on nodes based on resource requirements and constraints. Self-healing restarts failed containers, replaces unresponsive pods, kills pods that fail health checks. Horizontal scaling scales applications up/down based on CPU, memory, or custom metrics, service discovery and load balancing. Exposes containers via DNS names and distributes traffic. Rolling updates and rollbacks deploys new versions with zero downtime. Rolls back on failure, secret, and config management. Injects sensitive data and configuration without rebuilding images. Architecture, control plane IPI server, scheduler, controller manager, etcd cluster state store. Worker nodes, kubelet, kubeproxy, container runtime, containered.
What is a Kubernetes pod?
A pod is the smallest deployable unit in Kubernetes. It represents one or more containers that share the same network namespace. Containers in a pod communicate via
Localhost.
Share the same storage volumes. They can read/write the same mounted volumes, are co-scheduled, always land on the same node, and are started/stopped together. When to use multi-container pods. Sidecar pattern, a helper container, for example, log shipper, proxy like Envoy, runs alongside the main app. Init containers run setup tasks, DB migrations, config fetching, before the main container starts. Important, pods are ephemeral. Don't deploy pods directly. Use a deployment, stateful set, or daemon set to manage them.
What is a Kubernetes deployment?
A deployment is a controller that manages the desired state of pods via replica sets. It handles creation, scaling, updates, and rollbacks. Example.
Code API version, app/v1 kind deployment metadata, name, my app spec, replicas 3 selector, match labels, app, my app template, metadata, labels. App, my app spec, containers, name, app, image, nginx 1.25, ports, container port, 80, resources, requests. CPU 100M, memory 128 MB, limits, CPU 250M, memory 256 MB.
Key fields.
Replicas 3.
Maintains exactly 3 pod instances.
Selector match labels.
Tells the deployment which pods it owns.
Resources.
Always set requests/limits to enable proper scheduling. Update strategies.
Rolling updates.
Default gradually replaces old pods with new ones.
Recreate.
Kills all old pods before creating new ones, causes downtime.
What is a Kubernetes service?
A service provides a stable network endpoint for a set of pods, enabling reliable communication even as pods are created and destroyed. Service types. Cluster IP default. Internal-only IP, reachable only within the cluster, used for inter-service communication. Node port exposes the service on a static port, 30,032,767. On every node's IP, good for development. Load balancer provisions an external load balancer on cloud providers like AWS, GCP, Azure. Standard way to expose services to the internet. External name maps a service to a DNS name, CNIME, used for referencing external services. Example.
Code API version, v1 kind service metadata, name my service spec, type node port selector, app my app ports port 80, target port 8080, node port 30007. Port
Is the service port.
target port,
Is the container port.
node port.
Is the externally accessible port on each node.
What is the purpose of Kubernetes config maps and secrets?
Both decouple configuration from container images, but they serve different sensitivity levels. Config maps store non-sensitive key-value pairs, feature flags, config files, URLs.
Code kube control create config map app config backslash, from literal equals log level equals info backslash, from file equals config YAML.
Secrets store sensitive data, passwords, tokens, TLS certs. Values are base 64 encoded, not encrypted by default.
Code kube control creates secret generic dbcreds backslash, from literal equals username equals admin backslash, from literal equals password equals s3 cure.
Consuming them in pods, as environment variables.
Env from,
Or individual.
value from.
References, as mounted files, projected into a volume at a specified path. Security note, enable encryption at rest for secrets in etcd and consider external secret managers, Vault, AWS Secrets Manager, sealed secrets, for production.
What is a Kubernetes namespace?
Namespaces provide logical isolation within a single cluster. They scope resource names, access policies, and resource quotas. Default namespaces,
Default.
where resources go if no namespace is specified.
Kube system.
Cluster components, DNS, metric server, etc.
Kube public.
Publicly readable resources, rarely used.
Kube node lease.
Node heartbeat data, common commands.
Code kube control create namespace dev. Kube control get pods and dev. Kube control config set context current namespace equals dev.
Best practices, use namespaces to separate environments, dev, staging, prod. Or teams, apply resource quotas to limit CPU/memory per namespace. Apply network policies to restrict traffic between namespaces. Use RBAC to control who can access which namespace.
What is a stateful set in Kubernetes?
A stateful set manages stateful applications, databases, message queues, distributed systems that require stable identity and persistent storage. What stateful sets guarantee that deployments don't? Stable pod names, pods are named.
Stateful set 0.
Eh.
Stateful set 1.
Etc. and keep their identity across restarts, ordered deployment/scaling. Pods are created sequentially, 0, then 1, then 2, and terminated in reverse order. Stable network identity. Each pod gets a predictable DNS name via a headless service, persistent storage. Each pod gets its own persistent volume claim that follows it across rescheduling. When to use, databases MySQL, PostgreSQL, MongoDB, message brokers Kafka, RabbitMQ, distributed storage, Elasticsearch, Cassandra. When NOT to use, stateless web apps, IPIs, workers, use a deployment instead.
How do you scale a deployment in Kubernetes?
Manual scaling.
Code kube control scale deployment my app replicas equals 5.
Declarative scaling, update.
Spec replicas.
In the manifest and apply.
Code kube control apply F deployment YAML.
Automatic scaling with HPI, horizontal pod autoscaler.
Code kube control autoscale deployment my app backslash CPU% equals 50 min equals 2 max equals 10.
The HPI checks metrics every 15 seconds and adjusts the replica count to keep average CPU utilization around 50%. Check scaling status.
Code kube control get HPA, kube control get deployment my app.
What is a daemon set?
A daemon set ensures that exactly one pod runs on every node or a subset of nodes. In the cluster, common use cases, log collectors, Fluent, FileBeat, Promtail. Monitoring agents, Node Exporter, Datadog Agent, network plugins, Calico, Cilium, kubeproxy, storage daemons, Ceph, Gluster FS agents, node targeting. By default, a daemon set runs on every node. Use.
Node selector.
Or
Affinity.
rules to target specific nodes. Daemon set pods tolerate taints that would normally prevent scheduling. Key difference from deployments. Deployments run N replicas distributed across nodes. Daemon sets run exactly one pod per node.
How do you update a running deployment in Kubernetes?
Option 1. Update the image directly.
Code kube control set image deployment / my app equals nginx 1.25.
Option 2. Edit the manifest and apply.
Code kube control apply f deployment YAML.
Monitor the rollout.
Code kube control rollout status deployment / my app.
Roll back if something goes wrong.
Code kube control rollout undo deployment / my app. Kube control rollout undo deployment / my app to revision equals 2.
View rollout history.
Code kube control rollout history deployment / my app.
Kubernetes performs a rolling update by default, gradually replacing old pods. Configure.
Max surge.
And
Max unavailable.
to control the rollout pace.
What is the difference between Docker IDD and COPY?
Both copy files from the build context into the image, but they differ in behavior. COPY, straightforward file copy, does exactly what it says.
Code COPY config JSON /app config JSON. COPY src / app src /.
IDD does everything COPY does, plus auto-extracts compressed archives.
tar gz tar bz2
Into the destination, supports URLTCS as a source, downloads the file during build.
code idd myapp tar gz /app idd https / example.com config json /app /.
Best practice, always prefer.
COPY
Unless you specifically need tar extraction.
IDD
Has implicit behavior that can cause surprises. For downloading files, use
RUN curl
or
RUN wget
instead of,
IDD's URL.
so you can verify checksums and control caching.
How do you optimize Docker images?
1. Use small base images.
Alpine
~5 MB instead of
Ubuntu
~75 MB. Distroless images for production, no shell, no package manager. 2. Multi-stage builds build in one stage, copy only artifacts to the final stage.
code FROM node 20 Alpine IS build WORKDIR /app COPY package asterisk JSON /RUN npm COPY RUN npm run build FROM engine X Alpine COPY from equals build /app /dist /usr /share /engine X /HTML.
3. Layer caching, order instructions from least changing to most changing. Copy dependency files first.
Package JSON
Install, then copy source code this way.
npm install
Is cached when only source code changes. 4. Use
Docker ignore
exclude
node modules / git /
test files, docs, etc. 5. Minimize layers, combine related
RUNs
commands with
and code run apt-get update and an apt-get install ycurl and an rm ref/var/lib/apt/list/**.
6. Pin versions use specific tags
Node 20.11 Alpine.
instead of
Latest.
for reproducible builds.
How do you debug a running Docker container?
View container logs.
Code docker logs my container. Docker logs f my container hash stream in real time. Docker logs tail 100 my container hash last 100 lines.
Get a shell inside a running container.
Code docker execute my container /bin/sh. Docker execute my container /bin/bash.
Inspect container metadata, networking, mounts, config.
Code docker inspect my container. Docker inspect format. State status my container.
View resource usage.
Code docker stats my container.
View running processes inside the container.
Code docker top my container.
Copy files out for inspection.
Code docker cp my container /app/log/errorlog/errorlog.
What is a Docker multi-stage build?
A multi-stage build uses multiple
FROMs.
statements in a single Docker file. Each stage can use a different base image, and you selectively copy artifacts from one stage to another. Why? The final image contains only the runtime and the built artifact, no compilers, build tools, source code, or dev dependencies. Example, Go app.
Code FROM Galling 1.22 is builder WORKDIR/app COPY GoMod GoSum /RUN GoMod download COPY RUNCGO enabled =0 Go build myApp FROM Alpine 3.19 RUN app no cache add ca certificates COPY from =builder/app/myApp/myApp ENTRYPOINT/myApp.
Result, build stage, ~1 GB full Go SDK. Final image, ~15 MB just Alpine plus the binary. Benefits, smaller images, faster polls, reduced attack surface, cleaner separation of build and runtime concerns.
How does Docker handle networking?
Docker provides several network drivers. Bridge, default, creates an isolated virtual network on the host. Containers on the same bridge can communicate by container name, DNS. Best for single host setups.
Code Docker network create mynetwork. Docker run network equals mynetwork name app1 engine x. Docker run network equals mynetwork name app2 alpine ping app1.
Host, the container shares the host's network stack directly. No port mapping needed, but no network isolation. Used for performance-critical workloads.
Code Docker run network equals host engine x.
Overlay spans multiple Docker hosts. Used in Docker Swarm or with other orchestrators for multi-host container communication. None completely disables networking. Used for batch jobs or security-sensitive containers. Macflin assigns a MIC address to the container, making it appear as a physical device on the network. Used for legacy apps that expect to be on the LIN.
What is the difference between Docker Swarm and Kubernetes?
Both are container orchestration platforms, but they differ significantly. Docker Swarm, built into the Docker engine, no extra installation, simpler to set up and learn. Uses the same Docker Compose YAML format, manual scaling, basic scheduling, smaller community and ecosystem, good for small to medium deployments, Kubernetes. Separate platform with a steeper learning curve, much richer feature set, HPI, RBAC, CRDs, operators, ingress, etc. Auto-scaling, advanced scheduling, affinity/anti-affinity rules, massive ecosystem, Helm, Istio, Argo CD, Prometheus, etc. Industry standard for production container orchestration. Supported by all major cloud providers, EKS, GKE, IKS. Bottom line, Kubernetes is the industry standard for production workloads. Docker Swarm is suitable for simpler setups where ease of use is prioritized over features.
How do you remove unused Docker resources?
Remove everything unused: containers, images, networks, build cache.
Code Docker system prune A.
More targeted cleanup.
Code Docker container prune hash stop containers. Docker image prune a hash unused images. Docker volume prune hash unused volumes. Docker network prune hash unused networks. Docker builder prune hash build cache.
Check disk usage.
Code Docker system DF.
Caution:
Docker volume prune.
deletes data volumes not attached to any container. Make sure you don't have stop containers whose data you still need.
What is Docker Build Kit?
Build Kit is Docker's next-generation build engine, enabled by default since Docker 23.0. Key improvements over the legacy builder: parallel execution, independent build stages run concurrently, better caching, smarter layer caching, and cache import/export. Secret mounts, pass secrets during build without baking them into image layers.
RUN mount equals type equals secret. ID equals mysecret cat /run /secrets/mysecret.
SSH forwarding, use host SSH keys during build for private repo access. Build output, colored, structured progress output. Cache backends, export/import cache to registries or local directories for CI speedups. Enable build kit if not default.
Code export Docker build kit equals 1 Docker build.
How do you limit container resource usage?
Use
Memory.
and
ZBus.
flags to constrain resources.
Code Docker run memory equals 512 MCPUS equals 1.5 engine X.
Memory options.
Memory equals 512 M.
Hard memory limit, container is 00M killed if exceeded.
Memory reservation equals 256 M.
Soft limit, guaranteed minimum.
Memory swap equals 1 G.
Total memory plus swap limit, CPU options.
CPUS equals 1.5.
Use up to 1.5 CPU cores.
CPU shares equals 512.
Relative weight when CPU is contended, default is 1024.
CPU set CPUS equals 01.
Pin to specific CPU cores in Docker Compose.
Code services app, image, nginx deploy, resources, limits, CPUS 1.0, memory 512M, reservations, CPUS 0.25, memory 128M.
How does Kubernetes handle high availability?
Kubernetes achieves HI at multiple levels. Control plane HI, run multiple IPI server instances behind a load balancer. etcd uses Raft consensus across 3+ members for data replication, multiple scheduler and controller manager instances with leader election, application HI. Replica sets ensure the desired number of pod replicas are always running. Pod anti-affinity spreads replicas across different nodes/zones. Pod disruption budgets guarantee a minimum number of pods stay available during maintenance, health checks, liveness plus readiness probes. Detect and restart unhealthy pods, node-level HI. If a node fails, its pods are automatically rescheduled to healthy nodes after a configurable timeout. Cluster autoscaler adds new nodes when pods can't be scheduled due to resource constraints. Cloud-managed clusters, EKS, GKE, IKS. Offer managed, multi-zone control planes.
What is the role of kubelet in Kubernetes?
The kubelet is the primary agent that runs on every worker node. It is responsible for pod lifecycle management, receives pod specs from the IPI server, and ensures the described containers are running and healthy. Health monitoring, executes liveness, readiness, and startup probes, restarts failed containers. Resource reporting, Reports node status, capacity, and resource usage back to the control plane, volume management. Mounts config maps, secrets, PVCs, and other volumes into pods. Container runtime interface communicates with the container runtime, containered CRIO, via the CRI standard. Static pods can run pods defined in local manifest files, used for control plane components. The kubelet does NOT manage containers that were not created by Kubernetes.
How do you check logs of a running pod in Kubernetes?
Basic log retrieval.
Code kube control logs my pod.
Stream logs in real time.
Code kube control logs f my pod.
Multi-container pods specify the container name.
Code kube control logs my pod C sidecar.
Previous container instance useful after a crash.
Code kube control logs my pod previous.
Show recent logs only.
Code kube control logs my pod since equals 5m. Kube control logs my pod tail equals 100.
Logs from all pods matching a label.
Code kube control logs lapp equals my app all containers.
For production log aggregation, uses centralized logging stack, EFK, Elasticsearch plus Fluent plus Kibana, or Loki plus Promtail plus Grafana.
What are Kubernetes labels and selectors?
Labels are key value pairs attached to Kubernetes objects for identification and organization.
Code metadata's labels, app, my app, env, production, tier, frontend.
Selectors filter objects based on their labels, equality-based.
Code kube control get pods lapp equals my app. Kube control get pods lenv equals staging.
Set-based.
Code kube control get pods lenvin production staging. Kube control get pods tier notin backend.
Where selectors are used, services route traffic to pods matching.
Selector.
Deployments manage pods matching.
Spec selector match labels.
Network policies apply rules to pods matching label selectors. Node selectors schedule pods on specific nodes. Labels are the primary mechanism for loose coupling between Kubernetes resources.
What is a Kubernetes ingress?
An ingress manages external HTTP/HTTPS access to services within the cluster. It provides host-based and path-based routing, TLS termination, and name-based virtual hosting. Example.
Code API version, networking Kubernetes EO/v1, kind, ingress metadata, name, my ingress annotations, engine x ingress Kubernetes EO/rewrite target, /spec, TLS, hosts. MyAppCom secret name, TLS secret, rules, host, MyAppCom, HTTP, paths, path/API, path type, prefix, backend, service. Name API service port, number 8080, path type, prefix, backend, service, name frontend service. Port number 80s.
Important. An ingress resource requires an ingress controller to function, engine x ingress controller, Trefic, HA proxy, a WS, a LB ingress controller, etc. The ingress resource is just the routing configuration. The controller does the actual traffic routing.
What is the difference between horizontal pod autoscaler, HPI, and vertical pod autoscaler, VPI?
Both automate scaling, but in different directions. HPI, horizontal pod autoscaler, scales the number of pods up or down based on CPU, memory, or custom/external metrics. Best for stateless, horizontally scalable workloads, web servers, IPIs.
Code kube control autoscale deployment my app /CPU % equals 50 min equals 2 max equals 10.
VPI, vertical pod autoscaler, adjusts CPU and memory requests /limits of existing pods, requires pod restart to apply new resource values. Best for workloads that can't scale horizontally, single-instance databases, batch jobs. Operates in 3 modes.
Off.
Recommendations only.
Auto.
Applies changes.
Initial.
Set pod creation. Key considerations. HPI and VPI should generally not be used together on the same metric, for example, both scaling on CPU. They can conflict. HPI is far more commonly used in production. Both require the metric server to be installed in the cluster.
What is a Kubernetes persistent volume, PV, and persistent volume claim, PVC?
Kubernetes separates storage provisioning from storage consumption. Persistent volume, PV. A cluster-level storage resource provisioned by an admin or dynamically via a storage class. Represents actual storage, a WSEBS, GCEPD, NFS, etc. Persistent volume claim, PVC. A user's request for storage. Pods reference PVC-TCS, not PV-TCS directly. Example PVC.
Code API version, v1 kind, persistent volume claim, metadata, name, my PVC spec, access modes, read write once, storage class name, GP3, resources, requests. Storage 10 GB.
Access modes.
Read write once, RWO.
Mounted read-write by a single node.
Read only many, ROX.
Mounted read-only by multiple nodes.
Read write many, RWX.
Mounted read-write by multiple nodes requires NFS or similar. Reclaim policies.
Retain.
Keep the volume after PVC deletion, manual cleanup.
Delete.
Delete the underlying storage when the PVC is deleted. Dynamic provisioning via storage class eliminates the need to pre-create PV-TCS.
How do you upgrade a running application in Kubernetes?
Step 1. Update the image.
Code kubectl set image deployment / myapp app equals nginx 1.25.
Or edit the manifest and apply.
Code kubectl apply f deployment YAML.
Step 2. Monitor the rollout.
Code kubectl rollout status deployment / myapp.
Step 3. Verify the new pods are healthy.
Code kubectl get pods lapp equals myapp. Kubectl logs lapp equals myapp.
If something goes wrong, roll back.
Code kubectl rollout undo deployment / myapp.
Best practices for safe upgrades. Configure readiness probes so traffic is only sent to healthy pods. Set.
Max unavailable 0.
And
Max surge 1.
for zero downtime rolling updates, use.
Pod disruption budgets.
To maintain minimum availability, tag images with specific versions.
Nginx 1.25.3.
And never use.
Latest.
In production.
What is a Kubernetes job and cron job?
Job runs a pod to completion, one-time tasks. Kubernetes ensures the task finishes successfully, retrying if the pod fails.
Code API version, batch / v1 kind, job metadata, name, DB migration spec, backoff limit, 3, template, spec, containers, name, migrate. Image myapp latest command, Python, manage py, migrate, restart policy, never.
Cron job runs jobs on a schedule, like Linux cron.
Code API version, batch / v1 kind, cron job metadata, name, nightly backup spec, schedule, 02 asterisk, concurrency policy, forbid, job template, spec, template. Spec containers, name backup, image backup tool 1.0, command / backup sh, restart policy on failure.
Key fields.
Backoff limit.
Max retries before marking job as failed.
Concurrency policy. Allow. Forbid.
Or
Replace.
overlapping runs.
Successful jobs history limit.
/
Failed jobs history limit.
how many completed / failed jobs to keep.
How do you debug Kubernetes pods stuck in crash loop back off?
Crash loop backoff means the container starts, crashes, and Kubernetes keeps restarting it with increasing backoff delays. Step 1. Check the logs.
Code kube control logs my pod, kube control logs my pod previous.
The
Previous.
flag shows logs from the last crashed instance. Step 2. Describe the pod for events and error details.
Code kube control describe pod my pod.
Look at the events section and last state for exit codes and reasons. Step 3. Common causes and fixes. Exit code 1. Application error. Check logs for stack traces, missing config bad env vars. Exit code 137 OOM killed. Out of memory. Increase.
Resources limits memory.
Exit code 127 command not found. Check the
Command.
/
Args.
in the pod spec. Exit code 0 with restart. The process exits successfully, but the
Restart policy.
is
Always.
use a job instead or make the process long-running. Missing config map / secret, pod can't start because a referenced config doesn't exist. Step 4. Debug interactively.
Code kube control run debug image equals myapp command sleep 3600, kube control execute debug /bin /sh.
What are Docker namespaces and C groups? How do they contribute to containerization?
Namespaces and C groups are Linux kernel features that provide the foundation for container isolation. Namespaces isolate what a process can see. PID, each container has its own process tree. PID1 is the main process. NET, each container gets its own network stack, interfaces, IP routing. MNT, each container has its own file system mount points. UTS, each container can have its own hostname. IPC isolates interprocess communication, shared memory, semaphores. USER maps container UIDTKS to different host UIDTKS, rootless containers. C groups, control groups. Limit what a process can use, CPU time and core pinning. Memory limits with OOM killer enforcement. Disk I/O bandwidth, network bandwidth via TC, number of processes, PIDs. Together, namespaces provide isolation. The container thinks it's the only thing running. And C groups enforce resource limits. The container can't consume more than its share. This combination is what makes containers lightweight compared to VM-to-KES. No hypervisor or guest OS needed.
What is the difference between Docker volumes, bind mounts, and TMPFS?
Docker offers 3 storage options, each suited for different scenarios. Volumes managed by Docker, stored in Docker's storage directory.
/var/lib/docker/volume/.
Best for persistent data in production, can be shared between containers and backed up easily.
Code docker run vmyvolume /app/data engine x.
Bind mounts host file system. It maps a specific host path directly into the container, best for development, live code reloading. The container can modify host files. Be careful with permissions.
Code docker run v/home/user/project/app engine x.
TMPFS in memory. Stored in the host's RIM only, never written to disk. Data is lost when the container stops. Best for sensitive data, secrets, session data, or temporary caches.
Code docker run tmpfs/app/tmp engine x.
Decision guide, need persistence. Use volumes, need to share host files with the container. Use bind mounts, need fast, ephemeral, non-persistent storage. Use TMPFS.
How do you secure a Docker container?
1. Use minimal base images. Alpine, Distroless, or Scratch. Fewer packages equals fewer vulnerabilities. 2. Run as non-root.
Code run adducer d abusor, user abusor.
3. Drop all capabilities and add only what's needed.
Code docker run capdrop equals ill capadd equals netb indservice engine x.
4. Use read-only file system.
Code Docker run read-only tmpfs/tmp nginx.
5. Scan images for vulnerabilities.
Code Docker scout cvs image, latest.
Or use tools like Trivy, Gripe, Snike. 6. Don't store secrets in images. Use runtime injection via environment variables, Docker secrets, or mounted files. 7. Pin image versions. Use digest-based references for maximum reproducibility.
Code FROM nginx at SHA-256, ABC 123.
8. Enable Docker content trust for image signing.
Code export dockercont enttrust equals 1.
9. Limit resources to prevent DOS.
Code Docker run memory equals 256 MCPUS equals 0.5 PIDs limit equals 100 nginx.
How do multi-stage builds improve security in Docker?
Multi-stage builds improve security by minimizing what ends up in the final image. 1. No build tools in production. Compilers, package managers, and dev dependencies stay in the build stage and are discarded. 2. No source code in production. Only compiled artifacts are copied to the final image. 3. Smaller attack surface. Fewer binaries and libraries means fewer potential vulnerabilities. 4. Secret isolation. Build time secrets, NPM tokens, SSH keys, used in early stages don't leak into the final image. Example.
Code FROM Galling 1.22 is builder COPY. RUNGO build myap FROM GCREO/distrolist/static COPY from equals builder /go/myap/myap ENTRYPOINT/myap.
The final image uses distroless, no shell, no package manager, no unnecessary system utilities. An attacker who gains access to the container has almost nothing to work with.
What are immutable infrastructure principles, and how do they apply to Docker?
Immutable infrastructure means servers or containers are never modified after deployment. Instead of patching or updating a running instance, you build a new image and replace the old one. Core principles: build once, deploy everywhere. The same image runs in dev, staging, and production. No SSH into production containers. If something is wrong, fix the image and redeploy. Version everything. Each deployment is a tagged image.
V1.2.3.
Making rollbacks trivial. Infrastructure as code, Docker files, Compose files, and Kubernetes manifests are version controlled. How Docker enables this. Images are read-only layers. You can't accidentally modify the base. Container file systems are ephemeral. Changes are lost on restart, enforced immutability.
Read-only.
Flag prevents any file system, writes at runtime, registry-based workflow.
Build, push, pull, deploy.
With no manual steps, benefits. Reproducibility, easier rollbacks, elimination of configuration drift, simplified debugging. It's the same image everywhere.
How does Docker Content Trust, DCT, improve security?
Docker Content Trust provides cryptographic verification of image integrity and publisher identity using the update framework, TUF. What it does: signs images on push. The publisher's private key creates a digital signature. Verifies signatures on pull. Docker checks that the image hasn't been tampered with and comes from a trusted publisher. Prevents tag mutation. Once a tag is signed, it can't be silently overwritten. Enable DCT.
Code export dockercont enttrust equals 1.
With DCT enabled,
Docker push.
signs the image automatically.
Docker pull.
Refuses to download unsigned or tampered images.
Docker run.
Won't start unsigned images. Key management. Root key, offline master key. Keep this extremely secure. Repository key per image signing key. Delegation keys. Allow team members to sign images without sharing the root key. Limitation. DCT verifies the publisher, but does not scan for vulnerabilities inside the image. Combine with vulnerability scanning for full security.
How do you troubleshoot a Docker daemon issue?
Check daemon status.
Code systemtal status Docker.
View daemon logs.
Code journoctal u Docker service, no pager N100.
On Mac OS Docker desktop, check logs in.
/library/containers/com docker data/log/.
Restart the daemon.
Code sudo systemtal restart Docker.
Run in debug mode for verbose output.
Code sudo docker debug.
Or add
Debug true.
to
/etc/docker/daemon JSON.
and restart. Common issues and fixes. Cannot connect to Docker daemon, daemon isn't running, or the user isn't in the
Docker.
group disk full run.
Docker system prune A.
And
Docker volume prune.
DNS issues, configure DNS in.
/etc/docker/daemon JSON.
Eh.
DNS 8.8.8.8.
Storage driver errors, check.
Docker info.
For the storage driver, and review its logs.
What is the difference between Docker Stack and Docker Compose?
Both use YAML to define multi-container applications, but they target different environments. Docker Compose runs on a single host, used for local development and testing. Supports build context.
Build.
For building images locally, started with.
Docker Compose up.
Can use environment variable interpolation, profiles, and overrides. Docker Stack runs on a Docker Swarm cluster, multi-node, used for production deployments in swarm mode. Does NOT support?
Build.
Only pre-built images, started with.
Docker Stack deploys C Compose YAML misstack.
Supports swarm-specific features, placement constraints, rolling updates, replicas across nodes. In practice, most teams use Docker Compose for local development and Kubernetes, not Docker Stack. For production orchestration, since Kubernetes has become the industry standard.
How do you handle container networking in a multi-host Docker swarm?
Docker Swarm uses overlay networks to enable container-to-container communication across multiple hosts. Create an overlay network.
Code Docker network create D-overlay attachable mynetwork.
The
Attachable.
flag allows standalone containers, not just swarm services. To join, how overlay networking works, uses VXLIN to encapsulate container traffic and tunnel it between hosts. Each service gets a virtual IP, VIP. For built-in load balancing, Swarm's built-in DNS resolves service names to VIP tickets. Routing mesh allows any node in the swarm to accept traffic for any service, even if the service isn't running on that node. Encrypted overlay networks.
Code Docker network create D-overlay opt encrypted mynetwork.
Encrypts data in transit between nodes using ISEC. Ingress network, Swarm automatically creates an
Ingress.
overlay network for publishing ports externally.
How does Kubernetes handle stateful applications?
Kubernetes uses stateful sets to manage stateful workloads with guarantees that deployments don't provide. 1. Stable pod identity. Pods are named.
Name 0. Name 1.
Etc. and keep their identity across restarts. 2. Ordered operations. Pods are created in order 0, 1, 2, and terminated in reverse order 2, 1, 0. 3. Persistent storage per pod. Each pod gets its own PVC via
Volume claim templates. Code API version, app/v1 kind, stateful set metadata, name MySQL spec, service name, MySQL replicas 3 selector, match labels, app MySQL template. Metadata labels, app MySQL, spec, containers, name MySQL, image MySQL, 8, volume mounts, name, data. Mount path /var/lib/MySQL, volume claim templates, metadata, name, data, spec, access modes, read write once, resources, requests. Storage 10 GB.
4. Headless service required. A service with
Cluster IP none.
gives each pod a stable DNS name.
MySQL 0. MySQL default SVC cluster local.
Additionally, consider using Kubernetes operators, for example, MySQL operator, PostgreSQL operator, that automate backup, failover, and scaling for specific databases.
What are pod disruption budgets, PDBs?
A pod disruption budget defines the minimum availability that must be maintained during voluntary disruptions, node drains, cluster upgrades, maintenance. Example:
Code API version, policy/v1, kind, pod disruption budget metadata, name, myPDB spec, min available to selector, match labels, app, my app.
configuration options.
Min available to.
At least 2 pods must remain running at all times.
Max unavailable, 1.
At most 1 pod can be down at a time. Use one or the other, not both. What PDB-TCS protect against? Voluntary disruptions.
Kube control drain.
During node maintenance, cluster autoscaler removing nodes, rolling updates, voluntary pod evictions. What PDB-TCS do NOT protect against? Involuntary disruptions. Node crashes or hardware failures, OOM kills, kernel panics, best practice. Always create PDB-TCS for production workloads running multiple replicas.
How do you secure Kubernetes secrets?
By default, Kubernetes secrets are only base 64 encoded, not encrypted. Here's how to properly secure them. 1. Enable encryption at rest. Configure the IP iServer to encrypt secrets in etcd.
Code API version, API-server config Kubernetes EO/v1, kind, encryption configuration resources, secrets, providers, ESC, keys, name, key 1. Secret base 64 encoded key.
2. Use external secret managers. HashiCorp Vault with the Vault Agent Injector or CSI driver, a WS Secrets Manager with external secrets operator. Sealed secrets, encrypt secrets client-side so they can be stored safely in Git. 3. RBAC restrictions, limit who can.
Get. List.
Or
Watch.
secrets to only the service accounts and users that need them. 4. Avoid environment variables for sensitive data. Mounted files are safer because NVARs can leak through logs, error messages, and
/prog.
5. Rotate secrets regularly and audit access with Kubernetes audit logging. 6. Never commit plain secrets to Git. Use sealed secrets, SOPs, or external secret references instead.
What are Kubernetes admission controllers?
Admission controllers are plugins that intercept API requests after authentication and authorization, but before the object is persisted to etcd. They can validate or mutate requests. 2 types: validating, accept or reject requests, for example, reject pods running as root. Mutating, modify requests before they are stored, for example, inject a sidecar container into every pod. Built-in admission controllers examples.
Namespace lifecycle.
Prevents operations in non-existent namespaces.
Limit range.
Enforces default resource limits.
Resource quota.
Enforces namespace-level resource quotas.
Pod security.
Enforces pod security standards, replaced pod security policy.
Default storage class.
Assigns a default storage class to PVC-TCS. Custom admission controllers. Validating webhook configuration. Call an external HTTP endpoint to validate requests. Mutating webhook configuration. Call an external HTTP endpoint to modify requests. Use cases: enforcing security policies, injecting sidecars, Istio, setting default labels, validating image registries.
How does Kubernetes handle node failures?
Kubernetes detects and recovers from node failures automatically. Detection: 1. The kubelet sends heartbeats to the IPI server via node leases in
Kube node lease.
namespace. 2. If heartbeats stop, the node controller marks the node as
Not ready.
after.
Node monitor grace period.
Default 40 seconds. 3. After.
Pod eviction timeout.
Default 5 minutes. Pods on the failed node are marked for eviction, recovery. Pods managed by deployments/replica sets are rescheduled onto healthy nodes automatically. Stateful set pods wait longer before rescheduling to avoid split-brain scenarios with stateful workloads. Daemon set pods are recreated when the node comes back online. Cloud-managed clusters. Node auto-repair. The cloud provider detects unhealthy nodes and replaces them. Cluster autoscaler provisions new nodes if evicted pods can't be scheduled due to insufficient resources. Best practices: use pod anti-affinity to spread replicas across nodes. Set pod disruption budgets to maintain availability during node drains. Configure topology, spread constraints for zone-aware scheduling.
What is a Kubernetes mutating webhook?
A mutating webhook is an admission controller that dynamically modifies IPI requests before they are persisted to etcd. How it works: 1. A user submits a resource, for example, a pod, to the IPI server. 2. The IPI server forwards the request to the configured webhook endpoint. 3. The webhook returns a JSON patch with modifications. 4. The IPI server applies the patch and continues processing. Common use cases: sidecar injection. Istio's webhook automatically adds the Envoy proxy sidecar to every pod default values. Inject standard labels, annotations, or resource limits. Image registry rewriting. Redirect image pulls to an internal registry mirror. Security enforcement. Add security contexts, mount secrets, or inject init containers. Example configuration.
Code API version. Admission registration Kubernetes EO/v1 kind. Mutating webhook configuration metadata name. Sidecar injector webhooks name. Sidecar example com rules. Operations CREITE resources. Pods client config service name. Sidecar injector namespace kube system path/inject.
Ordering. Mutating webhooks run before validating webhooks, so mutations are validated after being applied.
How do you debug networking issues in Kubernetes?
Step 1. Verify pod connectivity.
Code kube control execute pod 1 ping pod 2 IP, kube control execute pod 1 curl HTTP//my service 8080.
Step 2. Check DNS resolution.
Code kube control execute pod 1 lookup my service, kube control execute pod 1 lookup my service default SVC cluster local.
If DNS fails, check the core DNS pods.
Kube control get pods kube system L Kubernetes app equals kube DNS.
Step 3. Inspect services and endpoints.
Code kube control get SVC my service, kube control get endpoints my service.
If endpoints are empty, the service selector doesn't match any running pods. Step 4. Check network policies.
Code kube control get network policy A, kube control describe network policy name.
Network policies may be blocking traffic. Try removing them temporarily to isolate the issue. Step 5. Debug with a temporary pod.
Code kube control run net debug image equals nicolaka / netshootit rm/bin/bash.
The
Netshoot
image includes tools like
curl dig tc pydump nmap
and.
hyperf.
Step 6. Check kubeproxy and CNI plugin logs for node-level networking issues.
How does Kubernetes Horizontal Pod Autoscaler, HPI, work internally?
The HPI controller runs a control loop that continuously adjusts the number of pod replicas based on observed metrics. How the loop works: every 15 seconds by default. 1. Queries the metric's IPI for current metric values, CPU, memory, or custom metrics. 2. Calculates the desired replica count using
Desired equals seal, current replicas asterisk, current metric / target metric.
3. Scales the deployment/replica set up or down toward the desired count. Example:
Code kube control autoscale deployment myapp / CPU percent equals 50 min equals 2 max equals 10.
if average CPU is 80% with target 50% and 4 replicas.
Seal 4 asterisk 80 / 50 equals 7.
Replicas, stabilization, scale-up delay by default. HPI can scale up immediately. Scale-down delay waits 5 minutes, configurable, before scaling down to avoid flapping. Metric sources, resource metrics, CPU and memory from metric server, custom metrics, application-specific, request/sec, queue depth, via Prometheus adapter. External metrics, metrics from outside the cluster, cloud monitoring, SQ length, check HPI status.
Code kube control get HPA, kube control describe HPA myapp.
How do you implement multi-tenancy in Kubernetes?
Multi-tenancy isolates workloads from different teams, customers, or environments within a shared cluster. 1. Namespace isolation. Each tenant gets their own namespace.
Code kube control create namespace team A, kube control create namespace team B.
2. RBAC role-based access control. Restrict each tenant to their namespace.
Code API version, RBAC authorization Kubernetes EO/v1, kind, role, metadata, namespace, team A, name, team role, rules, API groups, apps. Resources, pods, deployments, services, verbs, get, list, watch, create, update, delete.
Bind the role to a user or service account with A.
Role binding.
3. Resource quotas. Prevent any tenant from consuming all cluster resources.
Code API version, v1 kind resource quota metadata, namespace, team A spec, hard, request CPU 4, requests memory 8 GB, pods 20.
4. Network policies. Isolate network traffic between namespaces, deny all ingress by default, then allow specific flows. 5. Pod security standards. Enforce security baselines per namespace using
Pod security.
admission controller, restricted baseline privileged levels. For stronger isolation, for example, untrusted tenants, consider virtual clusters, vCluster, or dedicated clusters per tenant.
What is Kubernetes Cluster Federation?
Cluster Federation manages multiple Kubernetes clusters as a single logical unit, enabling workloads to span regions, clouds, or environments. Key capabilities: cross-cluster deployment. Deploy the same workload across multiple clusters from a single control plane. Geographic distribution. Run applications closer to users for lower latency. High availability. Survive the failure of an entire cluster or region. Policy consistency. Enforce uniform RBAC, network policies, and quotas across all clusters. Hybrid/multi-cloud. Manage clusters on AWS, GCP, Azure, and on-premises from one place. Tools: KubeFed, Kubernetes Federation v2, the official CNCF project for Federation. Admiralty multi-cluster scheduling. LeetCode, peer-to-peer multi-cluster resource sharing. Argo CD/Flux, GitOps-based multi-cluster deployment, more commonly used in practice. Trade-offs: adds significant operational complexity. Networking across clusters requires solutions like Submariner or Cilium cluster mesh. Most teams start with a simpler multi-cluster approach, using GitOps before adopting full federation.